This is the video over the 1.4 notes over polynomials. This is the last page of the notes. So now we're going to look at special products of polynomials. So essentially they are patterns that occur when you multiply certain types of binomials. Binomials meaning there are just two terms in the polynomial. So the first pattern that you can know is the product of the sum and difference of two terms. So if the terms are exactly the same, like here, xy, xy, and one is the sum and one is the difference, then a pattern is going to occur. You may remember this from multiplying conjugates. It's the same idea that happens there when you multiply conjugates. So let's just FOIL this and see what it comes out to and see if we can recognize a pattern. So if I multiply x times x, I get x squared minus xy plus xy minus y squared. So what's going to end up happening is every single time that you do that, these middle terms are going to cancel, leaving you with just x squared minus x squared minus y squared. So that's going to happen every time. Every time that you multiply the product, every time you find the product of the sum and difference of two terms, it's going to come out to that first term squared, so x squared, minus the second term squared, because those middle terms will cancel every time. Now the square of a binomial is also going to have a pattern. Let's just make a little room down here to try to see what that pattern is. X plus y, and we're going to square that, which we know means multiply it by itself, x plus y times x plus y. That's what that means. So now we're going to FOIL that, x squared plus xy plus xy, so I am right here, xy plus y squared. Now notice that you can combine those two middle terms, so that becomes 2xy. So x squared plus 2xy plus y squared. And so the pattern here is just that. It's going to end up being the first term squared and the last term squared. And then this middle term is going to be 2 times the product of the two terms. So you've got x squared, 2 times xy, and then plus y squared. That pattern is going to happen every single time. So let's write that down. And the pattern is similar for the difference of, if we have the difference and we're squaring that. So for that case, it's going to come out to x squared minus 2xy plus y squared. Let's see if we can apply those patterns to easily multiply these polynomials. All right, for A, I've got pattern number 1. So instead of actually FOILing that, I can just square the first term. So that's 7m squared minus the second term squared, 10 squared. So squaring all of that gives me 49m squared minus 100. Cool. Let's try B. Again, that first pattern. So we want to square the first term, 5x squared all squared, minus the second one squared, 8y to the 4th squared, 25x to the 4th for that first term, and then 64y to the 8th for the second. All right, and then looking at C, now we're looking at the square of a binomial. Square of a binomial. So remember the pattern. We're going to be looking at this first one since it's plus, since it's addition. Okay, so we want to square the first term. Plus 2 times the first term times the second term plus the second term squared. Okay, so squaring this gives me 64z. Multiplying all three of those together, 2 times 8 is 16, and 16 times 3 is 48. 3 squared is 9. Oop, forgot to put the square on my z. All right, that's it for that one. All right, looking at D. So again, squaring the first term. This time, because we've got subtraction, we're going to use the minus here. 2 times the first term times the second term plus that second term squared. All right, so we are going to simplify that, squaring everything inside parentheses here. We've got 16m squared. Multiplying gives us 8 times 9 is 72. Mn cubed plus 81 n to the 6th. All right, so that's how you apply those patterns for multiplying polynomials. Special cases. Now let's do 2 more problems that are just a slightly more challenging. So on A, we've got a binomial cubed instead of squared. But I could break that up and say s plus 4t squared times s plus 4t, right? That would be the same thing. Just breaking it up. Okay, so I'm going to use that pattern to square this first one, and then I will multiply it times that second binomial. So using the pattern on the first one, I've got s squared plus 2 times s times 4t plus 4t squared. Okay, so let me simplify that. S squared plus 8st plus 16t squared. Okay, now we want to multiply that by this second binomial, s plus 4t. Now there's no pattern here, so we're going to actually have to FOIL. So go ahead and multiply this s times both terms. S times s is s squared times s is s cubed. Okay, plus 4st, s squared t. Okay, now looking at our second term, I've got 8s squared t plus 32st squared. Now our third term, I've got 16t squared times s, so I'm going to put 16st squared. And then our last one, 16 times 4 gives me 64. And then that's going to be t cubed. Okay, so we have 6 different terms, and we want to combine like terms to finish this off. There is no other s cubed, so I'm just going to leave that. Now I'm looking for s squared t. Here's another s squared t. That's it, so I can combine those, make 12s squared t. Now I've got st squared and another st squared, so that gives me 48 st squared. And lastly, plus 64 t cubed. All right, let's move down to B. So let's look at this. It looks crazy, but let's see if we can find some pattern. Notice that 3p minus 2, it appears at the beginning of both, so those terms match. And then I've got 5q and 5q, so those terms match. Not only that, but if you look in the middle, we've got minus and plus. So this actually follows the pattern that we looked at first, that first pattern that we looked at. So because of that, let's use that pattern. So if you are multiplying the difference and the sum of two terms, you're just going to square the first term. So that would be 3p minus 2 squared. That's the first term squared. Minus the square of the second term, which is 5q squared. All right, now let's simplify that. 3p minus 2 squared is the other pattern that we actually just learned. So we want to use that pattern to multiply that. So notice that it's minus, so you're going to use the minus sign. So that's going to be 3p squared minus 2 times the first term times the second term plus the second term squared. Okay, so that was all just multiplying that. And then we've got a minus 5q squared, which is 25q squared. Okay, I'm going to simplify this on the left. That's going to be 9p squared minus, multiplying all of that, gives me 12p. And then plus 4 minus 25q squared. All right, see, that wasn't so bad. So we used this pattern of multiplying two binomials that have the same terms but different signs to get here. And then we used our other pattern to multiply this out, the square of a binomial. And then we simplified. All right, I hope that made sense, and y'all have a wonderful evening.